Calculate the efficiency of 25,000 watts of power shipped at 600 volts over the 10 ohm transmission line that we saw in the previous question. So same input power, this time we're changing our voltage from 500 volts to 600 volts. And we're seeing what impact that has on our overall efficiency. Now you'll recall when it was 500 volts, it was 0% efficient. So now we're adding 100 volts across our lines. We're going to check the new efficiency. So first step, as usual, let's get our current through the lines because we're imagining a series circuit here. P0 is V0 times I0. They give you our two input values. So it's going to be 25,000 watts divided by 600 volts to give me my current of 41.7 amps. Now let's figure out the loss. And again, we always use I squared R because I never changes. And we get 41.7 amps squared times 10 ohms. And that gives me a loss of 17,361 watts. So I started with 25,000 watts. The lines lose 17,361 watts. So now let's calculate our efficiency. And our efficiency is output, what actually gets to the city, divided by input times 100%. Now my output in this case will be whatever I started with, 25,000 watts, minus how much I lose in the lines, 17,361 watts, all divided by our original input, which was 25,000 watts, times 100%. And when we do the calculation, you should end up getting 31% efficient. So we went from 0% efficient to 31% efficient simply by adding 100 volts across the lines and lowering the current from 50 amps to 41.7 amps. So less heat would be generated, less losses.